Welcome to The Explainer, everyone. Today we are digging into something seriously fascinating. We're looking at an exclusive, almost behind-the-scenes secret regarding long-term electric vehicle ownership. I've got to say, I was completely blown away by what we uncovered when researching how to truly understand an EV's life cycle and, more importantly, how to protect that massive investment of yours. Okay, let's dive right into this. When folks talk about electric vehicles getting older, the conversation almost always goes straight to the main traction battery, right? Everyone is sweating over battery degradation. But here's what absolutely amazed me in the research. The real hidden financial threat, the actual second most expensive repair on a modern EV, is something else entirely. It's a part of the car that data shows most owners literally don't even know exists. Well, that is, until they're hit with an absolute monster of a repair bill. So what is it? It turns out the sources point directly to the power electronics. We're talking specifically about the DC-DC converter and the onboard charger, or OBC. The reports describe these modules as the absolute gateways or the bridges of your car. Think about it like this. Your EV's battery holds massive, massive high voltage. But your radio, your headlights, your computers, they run on a standard 12-volt system. The DC-DC converter safely steps down that huge voltage to run those everyday 12V systems. Meanwhile, the OBC acts as the bridge to the outside world. It takes alternating current from the grid and rectifies it into direct current to actually charge the main battery. They are, without a doubt, the unsung anchors of the whole EV ecosystem. Here is our roadmap for today. First, the hidden EV vulnerability. Second, brand-specific vulnerabilities. Third, the 4-year danger zone. Fourth, smart repair strategies. And finally, proactive EV maintenance. Let's get into it. Section 1, the hidden EV vulnerability. Now, as millions of EVs worldwide start exiting their factory warranty periods, the data is showing that these specific power modules are becoming a massive, massive focal point for the total cost of ownership. Back in older EV designs, the DC-DC converter and the OBC were totally separate boxes. But modern automotive engineering, it loves efficiency, it loves saving space, so they often combine these two functions into a single combo unit, sometimes called an integrated charging control unit. Now, sure, this makes them super efficient to manufacture and package, but it also creates a single, highly expensive point of failure. If just one side of that gateway goes down, the whole shebang needs attention. Moving right along to Section 2, brand-specific vulnerabilities. The sources make a really interesting point here. Failure in these components isn't just random bad luck. When we look at the data objectively, clear patterns actually start to emerge across different design architectures. Take the Hyundai and Kia E-GMP platform, for example. There have been global recalls where the ICCU suffers from current peaks that physically sever the feed to the 12V battery. Over at Stellantis, on the e-CMP platform from around 2020 to 2023, failures often pop up as the car just entirely rejecting AC charging. Renault Zoe uses this incredibly ingenious chameleon system, using motor windings for charging, but the research shows this puts significant thermal stress on the electronics over time. And for early pre-2019 Tesla Model S and X vehicles, well, vulnerabilities there were often linked to moisture sneaking into their liquid cooling circuits. What's really fascinating about looking at all this data together is that it highlights a massive, industry-wide architecture challenge. It's not just one bad car. It proves that as these platforms age, manufacturers and owners alike are having to transition from simply fulfilling warranties to actively managing the long-term life cycle of these incredibly advanced machines. Section 3, the 4-year danger zone. The timeline researchers have pinpointed here is totally eye-opening. The industry recognizes a critical failure window, and it usually opens right around the 4 to 5 year mark. That's the exact point where cumulative physical and chemical stresses finally breach the hardware's original design margins. Let's trace this out. In year 1, everything is factory pristine, beautiful. But by year 3, your standard 12V battery starts to experience sulfation and begins to weaken. By year 4, the special high-voltage liquid coolant, the stuff managing the heat in these electronics, begins to lose its anti-corrosive properties, which can cause micro-obstructions. Then, boom, year 5 hits. These cascading physical and chemical degradations mean the critical failure window is wide open. The wildest part? That degrading everyday 12V battery actually acts as a massive catalyst for a catastrophic system failure. And here is exactly how the literature describes that chain reaction playing out. First, you get thermal fatigue and aging coolant. Then, your 12V battery weakens. Because that 12V battery won't hold a proper charge anymore, the DC-DC converter is forced into a 100% duty cycle, desperately trying to keep it topped up. This constant, relentless overwork physically melts the solder joints and burns out the internal power transistors. Those are the MOSFETs and IGBTs. The system literally cooks itself to death trying to save a dying standard car battery. It's crazy. This brings us to Section 4, Smart Repair Strategies. Okay, before you hit the panic button, the sources do outline a strategic recovery matrix. This is how you can save some serious cash and navigate this like an absolute pro if a failure happens outside of your warranty. Always check your 8-year high-voltage warranty first. But if you are paying out of pocket, look at the stark contrast in these options. A traditional dealer replacement means swapping out the entire massive block, which is brutally expensive. But if you can find an elite, independent specialist, the research shows they can often perform a component-level repair. Replacing just a blown internal fuse or a burnt capacitor is a surgical, highly cost-effective alternative to throwing the whole module in the trash. The crucial point in all this data is really understanding the financial stakes. 4,000 euros. That, or sometimes significantly more, is what a reactive out-of-warranty dealership replacement can easily cost you. A bill of that size can severely and instantly tank the residual value of your electric vehicle. No one wants that. But contrast that with this. 300 euros. It's incredible to learn that 300 euros is the starting point for a smart, component-level repair by an independent specialist, someone who actually opens the box and solders in a new transistor. It is a massive, game-changing difference that alters the entire EV ownership equation. There is a catch, though. The sources provide a really stark warning if you decide to just buy a used, salvaged part online. Beware of component protection. Hardware is only half the battle these days. When you plug in a new or used power module, your car's main computer might straight up reject it because the VIN numbers don't match. You actually need proprietary tools like Tesla Toolbox or Stellantis Diagbox to bypass these software locks and code the module to your specific car. So it's not quite a simple plug-and-play situation. Finally, Section 5, Proactive EV Maintenance. The experts in the research outline a fantastic checklist to totally reframe how we handle EV upkeep. Instead of seeing it as a chore, think of maintenance as an insider risk mitigation strategy. First off, replace that 12V battery every 3 to 4 years. Do it even if the car turns on just fine. Honestly, it's the cheapest insurance you can possibly buy. Second, do not ignore the high-voltage coolant. Changing it at the 4 to 5 year mark prevents those micro-obstructions that cause thermal shock. Third, avoid running hydro accessories like cranking the AC for hours while parked. Fourth, during massive heat waves, avoid extreme high-power DC charging out in the direct sun. Seek some shade to reduce the thermal load on the system. And lastly, practice good software hygiene. Keep your car updated. Manufacturers are constantly releasing patches that smooth out those nasty electrical spikes that destroy hardware. I love how our source material perfectly summarized this. They wrote, maintenance of power electronics should be framed as a risk mitigation strategy for high-value assets. By following these proactive steps, you can confidently enjoy your electric car, completely eliminate those nagging doubts, and maximize your vehicle's uptime for years and years to come. So the research leaves us with this genuinely provocative final thought. Knowing what you know now, will you let a simple 100 euro 12V battery destroy a 4,000 euro power module? The choice is entirely up to you. Thank you so much for joining me as we explored this data today. I had a blast putting this together, and I genuinely hope these insights help you better understand and take full control of your EV's lifespan. Keep learning, keep optimizing, and I'll see you on the next explainer.